All right, thank you very much. So today we're going to talk about an emerging technology. It's identity-based segmentation, and it's an extension of microsegmentation using constructs that are not address port and protocol. And really, based on what you just heard, it's about attack surface, and microsegmentation is about eliminating that attack surface in the cloud and data center. So where did we come from and where are we going to? Where we came from is perimeters around data center assets. And once the attacker is inside the perimeter, they can move laterally. And really, the goal of microsegmentation is to shrink the perimeter around the boundary of the business application, so that business applications can only communicate amongst their own components or to satisfy independent dependencies, but they do not have free access within the cloud and data center. And the real motivation for doing this is because we're trying to eliminate lateral movement. And somebody is screen sharing. If you wouldn't mind disabling that so that I can share my screen, I would appreciate that. Thank you. And so really the point of lateral movement is that once that attacker breaches that perimeter, they can move laterally between all of those devices. And the majority of the access inside these perimeters is completely unnecessary. On the order of 90% of allowed access inside these data center perimeters, you simply don't need it. So as I said, microsegmentation is about shrinking that boundary around the business application. But the old way of doing microsegmentation is with networks. You put a firewall in place, you put a set of assets behind the firewall. But the problem is that the firewall is only good at revoking access. It can't validate the approved access. And this is critically important. Why? Look no further than SolarWinds, right? Or NotPetya, take your pick. In the case of NotPetya, you had a port 445 listener that was a file server. Piece of malware gets on and it starts scanning, right? It finds that listener. The listener doesn't know that it's the malicious software versus the legitimate software. And the firewall has no ability to validate that. So lateral movement occurs. The exact same thing happened with the SolarWinds breach. The attacker gains access to the monitoring system. Of course, all of your firewalls are configured to allow access so that your monitoring systems can monitor your business applications. Now, the attacker is on that monitoring system and they piggyback across all of that allowed access. So the transition from the traditional microsegmentation approach to the new model of identity-based segmentation is shifting from using basic addresses, ports, and protocols into using workload and machine identity. So what is the net benefit? Well, rather than talk about theory, let's just jump right into a demonstration of these capabilities. And then we'll talk about operational aspects. So the best way to do it is to actually show you an attack scenario. So what I'm going to use is just very basic lateral movement techniques. These are not advanced in any way. And the challenge I would have for you is when you implement microsegmentation, you should absolutely implement it in a way that can stop these sorts of attacks. So what I'm going to do is move laterally from an app server to a database server through a firewall that uses address, port, and protocol, layer 7 protocol validation, and it does threat detection and prevention. So I'm going to use 3 techniques. First, I'm going to figure out what paths of access are presently allowed by the firewall. And to do that, I'm just going to do a simple net stat. I'll find the connection to the database server. And now what I'm going to do is try to figure out the version of the database. To do that, I'm going to use any basic tools, telnet or otherwise, to tickle the port of the database and get the version information. Now I'm going to download some exploit code and bounce it against the database. And this is important. This exploit is known by the firewall. So when I download this code and I point it at the firewall, what it's going to do is detect it and stop it. But there's a really important point here as it pertains to using firewalls for microsegmentation versus using identity. So with the approach that we use for the firewall sees the connection, it analyzes it, it says, well, you're the right address, you're the right protocol, so come on through. So my point is that the firewall can't see into the workload to understand what's actually communicating here. And so it lets it go through even though it's malicious. There's a new way of accomplishing identity-based segmentation, and that's using the actual identity of the workloads themselves. So what I mean by that is this. What we do is, instead of looking at addresses, ports, and protocols like a firewall, we look up into the workload identity by fingerprinting the workload to understand what truly is communicating. Just like with other Zscaler products, ZPA is a great example, where it validates the identity of the user and the user's device and gives it a secure connection to a business application. We're doing the exact same thing for server workloads in the cloud and data center. So what does this look like? What it looks like is we deploy an agent to your system. We inventory all of the communicating software. We then build policies automatically to evaluate the attack surface and eliminate that attack surface. So there are 5 operational steps associated with identity-based segmentation. You need to build the segments. You need to create the policies. You need to update the policies as your environment changes. So let's walk through what that actually looks like in your environment. So when I come in here, the first thing you see is visibility. So visibility is really about inventorying assets and how they communicate in your environment. The panelists talked about this at length, which is you need to understand what the attack surface is. You need to understand how those entities interact. And right out of the box, with no configuration, what you get is a full topological map of your environment. So in this case, you're seeing Active Directory and all of the software and devices that communicate into Active Directory and what it communicates with. You can drill down to the device level within a segment. You can actually go down to the software level to understand how individual services are interacting within your environment. You can also see this topological map from a business perspective, where you want to understand what business services connect into the LSAS. You can see that it's the e-commerce platform, the e-commerce app tier, the e-commerce database tier, administrative desktop systems. If you want to understand which administrative desktop systems and what software, you can see very, very clearly exactly the software that's communicating into the services. Now, what we do with this information is we start to define the segment boundaries so that we can isolate those devices. So Active Directory is a great example of this. Everybody's familiar with it on the call, and we can use it to demonstrate these capabilities. So when we take Active Directory, you can define this yourself. You can define it through API, through integration with the CMDB, or you can use machine recommended objects. So if I were to search for machine recommended objects that are related to Active Directory, you can see this guy right here, which was created by a machine learning system that identified all of the assets that make up Active Directory, grouped it together into a segment that's ready for you to protect. So what do you do to protect it? You auto segment. Auto segmentation, you have to just give the object a name. I'll call it PS8011. And then we click rename. And what we're going to do is choose a policy object model. Most of our customers use the simple policy object model because it's simple. And now you tell the system what paths of communication you want to protect, all inbound, outbound, and internal. Now, this is a key distinction with traditional microsegmentation approaches. Traditional microsegmentation is only concerned with ring fencing, putting a boundary around inbound and outbound connectivity. But with Zero Trust, it's really about validating all paths of communication with something that is better than an address, port, and protocol. So we protect all paths by default, including internal paths within each device and between each device. There is absolutely no operational risk here because we set by default simulate block, which allows you to evaluate the impact of policies in your environment before you put them into full enforcement. You simply auto segment, and what the system does is grabs a set of identity-based policies, it squishes them down to its smallest possible form factor, and then it puts them into protection mode so that you can evaluate their impact. So this process typically takes about 30 seconds. While this is going, what I'd like to do is show you what these policies and their impact would be in the environment based on those attack scenarios that we were just going through. So we'll flip back to this view, and we're just going to zoom ahead on this demonstration. And really, we're going to do the same 3 approaches. In this case, what we're doing is building identity properties for the software. We then validate the identity properties on both sides of the connection. we're going to approve the user service to talk to the MySQL service. And what that means is all of those threat capabilities that I was using previously, the telnet to tickle the port, the MySQL admin to move laterally, the MySQL jackpot exploit code, those will not be allowed to communicate. So we've put the policy in place, and now we're going to try all of the attack scenarios that I did previously and see what the results are with the identity-based approach versus the firewall-based approach. So what you can see here is that the firewall-based approach allowed those connections, but the identity-based approach, because this malicious software does not pass the validation steps, it is not authorized to communicate. And you can see very clearly that it results in permission denied errors. So hopefully this is done. Yes. So we're back to Active Directory here. We've created the policies, 6 policies to protect Active Directory. This is absolutely the simplest way you can do microsegmentation. In this case, what you've got is one internal policy, one inbound policy, one policy covering all of the inbound paths of communication. And what the system did when it auto-segmented was it identified the set of resources that needed to be exposed external to the segment, and it identified all of the software and devices that needed to be able to connect into that segment. Your role as an operations team owning this system is not to build policies. It's to scrutinize the recommended policies. So for instance, if I came in here and I said, you know what, I don't want Nmap to be able to communicate, so I get rid of Nmap and I hit save. Instead of building the policies from the ground up, instead what I'm focused on is actually evaluating the policies that were recommended by the auto segment feature, scrutinizing them to ratchet them down. There's a very significant difference in operational cost starting from 0 versus scrutinizing what a system generated for you. Okay, so we've auto-segmented. We created these 6 simple policies to protect all paths of inbound, outbound, and internal communications. Now the system is doing real identity verification on all paths of communication in real time. And just like I showed you in that demo previously, what that actually translates to is that the system is validating under the covers that, in this case, DSReg to LSAS, that it's legitimately the DSReg software from Microsoft version 10.0.14393 that's talking to LSAS, again, over here, from Microsoft version 10.0.14393. So it does identity-based verification for all paths of communication in real time to ensure that it is only the authorized communicating software that is allowed to communicate. And as you can see, what that means is if an attacker were to gain access to the system, let's say it was NotPetya, the only thing that was allowed to communicate was the legitimate file services client with the legitimate file server. NotPetya comes in and it tries to scan. It's not even going to see the attack surface because it is not considered valid, approved, authorized software. So topological mapping of all communication paths, identity-based verification of every communication in real time, automatically builds the policies for you using the machine learning system to define the segment, define all of the required policies, and then at the end of the process, it validates that you have actually improved your security posture. So for instance, we've got PS8011 here. And let me just reset my view. So Active Directory, it was 81 times more exposed than it was before ZWS than after. What I mean by that is we evaluate the attack surface to quantify the value of ZWS in your environment. And we do that through direct observation. This isn't a guess or a model or anything. It is actual observation of learned attack paths that could reach the attack surface of Active Directory. So in this case, we found 12,290 attack paths that reach Active Directory. Only 151 of them were needed. We are protecting 100% of the attack surface of Active Directory with identity-based verification. You drill in one more level, you can see the same stats, but applied to the host. So 5,150 paths, 90 were needed. Go one level deeper, and you can actually evaluate the attack surface of individual listening business services. So in Active Directory, the DFSRS service was 46 times overexposed. There were 91 attack paths. Only 2 of them were actually needed, being used by one piece of legitimate, authorized, validated software. The attack surface is 100% protected. So to wrap this up, really the point here is that you've got massive attack surface in your data center. Over 90% of that attack surface simply does not need to exist. The question is, how are you going to eliminate it? The typical answer is microsegmentation, which is a network-based approach to eliminating attack surface. It's very cumbersome, and it doesn't actually stop lateral movement because attackers piggyback across the allowed access. Identity-based segmentation is a new take on microsegmentation. It uses machine and software identity to validate all communications. We apply machine learning to build the policies, validate connectivity, and then prove that the attack surface has actually been reduced through these statistics. So that's all the time I have today. Thanks for your attention, and thanks for participating today. Turning it back over to Kavitha.